Salutations, Internet. Good time zone. So, for the first time in at least several videos of me doing this, I don't have any general housekeeping thing. No new updates since the previous video. Nothing I really need to clarify from the previous episode that I am aware of, at least. So, with that in mind, I think I'm just going to dive right into this. So let's zoom in to the time position relationship and orbit equations we have here. We can see that we now have two new ones to play with. And this is actually going to be the jumping off point for the beginning of this episode, because we have equations to convert from theta to eccentric anomaly angle, where we can then do all of our fancy time calculations. But what we're lacking is the ability to go from the eccentric anomaly angle back to theta, so that we know after an amount of time has passed where we're going to be in the orbit. And there will be something about that later. So without further ado, I say let's start with the cosine equation here, and let's work it in reverse. So if I come over to here and I write it down, let's start with the cosine of the eccentric anomaly angle is equal to the eccentricity plus the cosine of theta. I don't like the way I wrote my theta there. Let me try that again. Of theta, much better, much better. 1 over 1 plus the eccentricity times the cosine of theta. All right, this is a good start. Let's bring the denominator up here, and I'm going to go ahead and distribute everything. We have the cosine of the eccentric anomaly angle plus the eccentricity times the cosine, and I'll try to make that look like 2 letters instead of 1, the cosine of theta times the cosine of the eccentric anomaly angle, and have that be equal to E plus the cosine of theta. All right. Well, we're trying to solve for theta, so let's put all of the theta terms over on one side. So that's going to be E times the cosine of theta times the cosine of the eccentric anomaly angle. That's going to be equal to eccentricity. No, it is not. I skipped a term. Minus the cosine of theta, there we go, is equal to now the eccentricity minus the cosine of the eccentric anomaly angle. All right, that's looking a lot better. We have 1, 2, 3, 4 terms up top, 1, 2, 3, 4 terms in the next line. Very good. So we will take out the cosine of theta, and just for my own peace of mind, I'm going to go ahead and write the rest of it times the eccentricity times the cosine of, no, not theta, the cosine of the eccentric anomaly angle minus 1. That's going to be equal to the eccentricity minus the cosine of the eccentric anomaly angle. Finish solving for the cosine of theta. Equal to E minus cosine of E over E times the cosine of E minus 1. Very nice. Very, very nice. And so that will be our cosine equation for the conversion from eccentric anomaly angle to true anomaly angle. It's very nice. And so one can reasonably assume that if we did that with fancy green, it's not just fancy green, that if we did that with cosine, we can do that with sine. So let's go ahead and copy that over. So we will have the sine of the eccentric anomaly angle is equal to square root of 1 minus e squared, 1 minus the eccentricity squared, times the sine of theta, all over 1 plus the eccentricity times the cosine of theta. All right. Move that down. We will do the same thing as before. I'm just going to fast forward through this part. I don't know if I'm going to delete this part or not. I can. And this is where things get problematic because we have a cosine of theta and we have a sine of theta. I don't remember which video I said it in, but it did point out that trig functions are nonlinear and they are very, very difficult, if not impossible, to extract in the information within from. They're just a huge pain in the neck, and if you can avoid it, it's definitely worth not doing that. So, okay, what are we to do here? Are we just going to give up on trying to find out what the sine of the eccentric anomaly angle is? No, we are not. Because I did something really sneaky. In a previous episode, quite without realizing that I was doing it, actually, go to 67%, we accidentally already derived the answer that we're looking for. In fact, that answer is right here. I'm going to rewrite it so that it's not as messy with all of these crossed out terms in them. So give me just one moment. Sine of theta is equal to the square root of 1 minus the eccentricity squared times the sine of the eccentric anomaly angle over 1 minus the eccentricity times the cosine, again making that look like two characters of the eccentric anomaly angle. And do that. There we go. Ultimately, painless, especially since we don't have to do anything with this nonsense up here. I am quite happy that I don't have to try to extract a theta from both a sine and a cosine function. That's just not something that should be allowable. So, very fortunately, we don't have to. And so now we've done, in both directions, sines and cosines. The last trig function that we have left to do is tangents. So let's give us some more space. And one can reasonably assume that if we take the tangent of theta, we can have that be equal to sine of theta over the cosine of theta. Right? Because if you remember from your trig days, this is the definition of tangent. This makes sense to follow through on. However, that is actually not the formula that we are going to go along with. We are going to look at the tangent half angle formula. And the formula for that is actually, I'm going to write it down here. It's going to be the tangent. Boy, I'm just feeling like making everything cursive today, aren't I? Just give me some more space. The tangent of theta over 2 is equal to the sine of theta. Okay, that's not bad. Over 1 plus the cosine of theta. So, why we are using the tangent half angle formula as opposed to the definition of tangent is going to be left as an exercise to the viewer. All right, I'm not going to spend a whole lot of time looking into that, but if you want to run through the equations, you are more than welcome to. Please post it in the comments section, and then we can all read your answers, and we can all find out together. That's the beauty of having a YouTube community. We can all better each other. Let's move on to actually doing this. So we're going to start with the sine, and I have it written off to the side here, but we're just going to plug this whole thing in. Even though I have it written off to the side, I'm just going to copy it from here. Square root of 1 minus the eccentricity squared times the sine of the eccentric anomaly angle over 1 minus the eccentricity minus the cosine of the eccentric anomaly angle over. Now we have 1 plus the cosine, which is going to be this other green box that I have here. Now, here's the problem. After I do this, it's going to make an equation that is 4 lines tall. And I'm not going to lie, while I can do that, that's a lot of work. I don't feel like doing that. So we're going to pull out one of the mathematician's favorite tricks. And we are going to multiply this by -1 over -1. And in doing that, as you can see, these denominators, I can barely fit both of them on the screen. These denominators here for both boxes are very close to one another, but multiplying at least, well, not just at least, multiplying one of them by -1 will flip the two terms within the denominator so that they can match up with one another. When they match up with one another, we can get rid of them, and then we're only dealing with the two numerators in the numerator and the denominator. Hopefully the wording makes sense, but if it doesn't, I will show you what I mean here very shortly. And in fact, I'm going to, instead of writing it up there, I'm just going to write it down here. And that becomes, there we go, cosine of the eccentric anomaly angle minus the eccentricity over the eccentricity, no, over 1 minus the eccentricity times the cosine of the eccentric anomaly angle. Like I said, this becomes 4 lines. But once we distribute this denominator of a denominator up to that 1 plus, to write the 4 lines again, but for the last time, 1 minus eccentricity squared times the sine of the eccentric anomaly angle over 1 minus e times the cosine of the eccentric anomaly angle all over 1 minus e times the cosine of the eccentric anomaly angle plus the cosine of the eccentric anomaly angle minus the eccentricity over 1 minus e times cosine of e. All right. This is a mess. But fortunately, that cancels out. And now it is significantly less messy. So now we have the square root of 1 minus the eccentricity squared times the sine, the eccentric anomaly angle over 1 minus e dotted with cosine of e plus e cosine of e minus e. All right. So that's a lot easier to deal with. And it'll be a lot easier once I tell you this next part. So this denominator can be broken down into, or it can be broken down, it can be factored into two products. We have 1 minus e times, what is in the notes, 1 plus the cosine of the eccentric anomaly angle. And so to write it down here, we have the tangent of theta by 2 is equal to the square root of 1 minus the eccentricity squared times the sine of the eccentric anomaly angle over 1 minus e times 1 plus cosine of e. And as a brief reminder, 1 minus, no, let's not do that in blue. Let's do that in the regular color. 1 minus e squared can then be broken down into 1 plus e and 1 minus e. And so once you've done all of the exponent math, here, let me write the left side down. Once all of the exponent math is done, you will have the square root of 1 plus the eccentricity over 1 minus the eccentricity. I had to confirm that to make sure. Check with my notes. Times, and now we have this over here, which should look familiar because this is what got us started on this crazy tangent, haha, to begin with. That is the tangent half angle formula, which very conveniently becomes the tangent of the eccentric anomaly angle over 2. And there you have it. Using tangents to convert from the eccentric anomaly angle to theta. And to go in the opposite direction is very easy. Tangent of the eccentric anomaly angle by 2 is going to be equal to, we just flip this around, so 1 minus e, or invert it, I should say, 1 minus e over 1 plus e times the tangent of theta over 2. And that is way better than anything else that we have worked with so far today. Now, ordinarily, I would give you all an example showing how all of these equations can be used. I'm not going to do that with this video. I'm electing not to do that with this video. Instead, I am probably between the next episode and maybe the episode after that or whatever. I am going to go ahead and do a far more in-depth video going through all of the, well, maybe not all of these equations, but at the very least a good chunk of all of these, and really show you how to properly use them. So I think I'm gonna stop here, but I would like to thank everybody for stopping by, and I hope you all have a great rest of your day.